Okay, now we're going to do problem number 26 in section 2.8, and it's a problem with two cars leaving an intersection at the same time. One's going south and one's going headed west. So again, this is number 26 in section 2.8, and if you look at the diagram there, they say, okay, this one car is going to be heading west and the other car heading south, and this is the starting point. What you need to know is that, well, because those are points on the compass, that's a 90-degree angle, and right triangle geometry tells us that if this side is, let's call it, has a distance of d1 between that point and that point, and so if that's called d1, and then this over here on the west side is called d2, and again those stands for the distances from the point, the starting point, to the point in time t. So at t0, they're both at time t0, they're both here at the starting point. And then let's say, you know, at another point in time, this car is at this point and this car is at that point. And so what you want to, at any point in time, we can figure out, describe the distances, because the Pythagorean theorem says that the distance of this hypotenuse right here, the distance between them, is going to be the square of the other two distances. So they want us to find out, it says express the distance between the cars, which would actually be this distance here. So if you've got car A down here and car B over here, and you want to find the distance between the two, it's a straight line between the two cars. So how you find that is by using, let's just say it's called distance. So the distance between the cars is equal to the sum of the squares of the other two lengths of that triangle. So it's going to be d1 squared plus d2 squared, and again those are the lengths of the sides of those on the triangle there. So it's d1, the distance between the cars at any point in time is d1 squared plus d2 squared. It's going to be this, actually it's going to be the square of the distance. So this hypotenuse here, which is the long side, of this triangle, where it says dist, that's the hypotenuse. That squared equals the other two, the sum of the other two sides squared. So it's dist squared equals d1 squared plus d2 squared. So if we want to solve for this, what they tell us is that one of the cars is headed at 30 miles per hour and the other one's headed at 40 miles per hour in the other direction. So distance equals rate times time. Okay, so car 1 is let's say d1, so d1 is going to equal to the rate that they are going, which, let's just say that's the car that's going 30. So that would be R is 30, or 30 miles per hour is the rate times t. So d1 in our equation is 30t, or 30 times t. d2 is equal to the rate of that car, which is 40 miles per hour, times t. So that one's distance can be, at any time t, is going to be 40 times t, whatever the time is in whatever the time is there. So let's just substitute those into our equation now. The distance between the two cars, d of t, at any time is now going to be 30t quantity squared plus 40t quantity squared, and that's actually the distance squared again, because it's the hypotenuse squared equals the sum of the squares of the other two sides of the triangle, and that's just from right triangle geometry. So we go ahead and square that out. We get that's going to be 900 t squared plus 1600 t squared is going to be equal to this d of t squared, which happens to be the distance between the two cars, which is what we want. So now we just need to take the square root of both sides, and we'll get d of t and is equal to the square root of 900 t squared plus 1600 t squared. Alright, and that's going to be equal to 2500, the square root of 2500 t squared, and that has a perfect square. 2500, we can break that apart, and so that gets 2500, the square root of 2500 times the square root of t squared. Well, the square root of 2500, if you do that on your calculator, is 50, and the square root of t squared is just t. So the distance between those two cars at any point in time t is equal to 50t. So our function that is in terms of time is 50 times t, where t is at any point in time. Alright, so that's our answer there, and that should do it.